Right, howdy. So, what would we like to look at today? I think we're going to look at position. Okay. So, when we're doing these things, when we're doing physics, we have to sort of put a map over the world. And we'll talk about this a little more with vectors. That's almost directly what it is. But we have to, in some way, put something over the world so we can do math on it. Physics is, in the long run, an application of math to the real world so that you can analyze the real world in a quantitative manner in order to test ideas or conceptual ideas about the world. So the math gets stuck in there, and if we didn't have the math, we wouldn't care about it at all. If we didn't have math in physics, then it would be philosophy. In fact, we could keep the math in physics and it would still be philosophy. If we didn't have the math in, instituted in such a way that we could do determinative experiments, it would be philosophy. And we'd still be arguing about it just like we'd argue about the mind body problem. So, you know, we talked about this a lot earlier. At one point, Lucretius thought the elements weren't things like little tiny agglomerations of protons and neutrons with electrons spinning around them that, not technically spinning, but orbiting around them in these sort of random orbitals that that describe different kinds of matter. Rather, he thought that the elements were earth, air, water, and fire. Those were atoms or little tiny nuclei of those, in a sense. Maybe not nuclei, but they're little tiny atoms of fire, little tiny atoms of water. We'd still be arguing stuff like that if we hadn't gotten to the point, basically with Galileo, that we could compare our ideas with the world through mathematics in a determinative way, which is called experiment. So the first way to do that, and this is something that Galileo had to do, is we have to figure out something about the position, right? The position, how do we determine where something is? And I mean, you can think about that in terms of a chart, and maybe we'll talk about that a little more next time. But basically, what you're doing there is you're saying, okay, we've got this standard. We talked about standards last time. And if I were to have a hallway, right, I could determine there was a reference point here and say, okay, if I have these different doors over here, how many of these standard objects does it take to get from here to here, right? So let's say we get 5 of them, and each one of these is 1 yard. Then this is 5 yards, right? 1, 2, 3, 4, 5. So we've taken that idea of a standard previously, which is going to help us take the world and put it into mathematics. We've added this reference point here. This is 0 yards from the reference point. This is 5 yards from the reference point. And we can use that to discuss what we're doing, what's actually happening. So, I'm going to say the position of an object is the directed distance from a commonly, I should put its agreed upon reference. Okay, and so here, these outside doors, those are my commonly agreed upon reference point, and to get to the object, which is my office door, you have to walk 5 yards. Okay, it doesn't sound too horrible. But a couple of things we want to do is we want to figure out, well, what do I mean by directed? Well, directed is basically direction, right? So the direction from the reference point is indicated by the sign of the position in one dimension. In 2 dimensions, it's going to be a little more complicated. But for 1 dimension, it's just the sign. So this is my reference point here, 0. Going 5 yards out this way gets me to the point 5 yards. Going 5 yards back this way gets me the point minus 5 yards. And right is positive, left is negative in this case. All right, so that's our position. That's sort of what it means. And the sign, that's what the directed means, is that is it to the left or to the right? Which is kind of important, right? If 5 yards, big deal, 5 miles, you might want to know which way to turn, left or right. Okay, then we get to the reference point. What is our reference point? This is called the origin. So x equals 0. So again, if we go back to the example, the origin, the reference point, these double doors, is 0 feet. And then the first office, my office, is 5 yards or 15 feet from the door. Second office, let's say Chowkey's office, is 10 yards from the door or 30 feet, and so on. Dr. Brown's office would be 15 yards. Okay? Seems pretty reasonable. So you're saying those are really big offices. The offices aren't that big, but I wish they were. So hopefully that's sort of sufficient. What I just said is, what we need to do to define a position. It's not a lot. We just have to choose a spot that we consider 0, and everybody has to agree that it's 0. Or we have to agree on how to switch between zeros. We're not going to worry too much about that here. We would in a more advanced class. But in this class, we're going to just say we have this 0 called the origin, 0 feet from the double doors that go outside. That's 0. Then we get to my office. That's 5 yards away. And the position is 5 yards. The statue outside the building out here, right? That's going to be minus 3 yards, let's say, probably farther. So that's all we mean by position. Okay. Next, I'll do a quick example, and then I'll come back and talk about velocity.